So what exactly is artificial intelligence? Now, I'm not an AI researcher or computer scientist, just someone fascinated by this technology that's quietly reshaping our world. In this video, we're going to explain what AI really is in very simple terms, breaking down the mystery behind how these systems actually work. By the end of this video, you'll be able to explain AI to anyone who asks, from your parents to your friends, without getting lost in technical jargon. We're not diving into the politics or ethics debates here, just the core ideas and concepts that make AI tick. So without further ado, let's get into it. So what exactly is artificial intelligence? The term artificial intelligence sounds futuristic, almost sci-fi. We imagine robots that think and feel like humans. But the reality is both simpler and stranger than that. At its core, AI is just software, programs written by humans, designed to perform tasks that normally require human intelligence. We're talking about things like recognizing patterns, making decisions, understanding language, or learning from experience. But here's the critical difference. Traditional computer programs follow explicit instructions, step by step, like a recipe. If this happens, do that. If that happens, do this other thing. AI, on the other hand, learns patterns from examples. You don't tell it exactly what to do in every situation. Instead, you show it thousands or millions of examples, and it figures out the patterns on its own. Think of it this way. Teaching a regular program to recognize a cat means writing rules like has pointy ears, has whiskers, has 4 legs. But what about a cat sitting down, where you can't see all 4 legs? What about a hairless cat with barely visible whiskers? Teaching AI to recognize a cat means showing it 10,000 pictures of cats until it learns what catness looks like, even in situations you never explicitly programmed. Here's an analogy that makes this clearer. Imagine teaching a child to ride a bicycle. You don't hand them a manual with instructions like tilt 3.7 degrees left when turning, apply brake pressure of exactly 40 newtons when stopping. That would be absurd. Instead, the child tries, falls, adjusts, tries again, and gradually develops an intuition for balance and steering. Their brain is building an internal model of how bicycles work through experience, not through following a rulebook. This is essentially what modern AI does. It builds internal models by processing huge amounts of data, making mistakes, and adjusting its internal parameters millions of times until it gets better. The technical term for this process is machine learning, and it's the foundation of almost every AI system you interact with today. But this idea didn't start with modern computers. Back in 1950, a British mathematician named Alan Turing asked a revolutionary question: can machines think? Now, Turing realized this question was actually impossible to answer, because we don't even fully understand what thinking means for humans. So instead, he proposed something brilliant, what's now called the Turing test. You can search it on Google to find out more about this. The test works like this. You have a human judge having text conversations with 2 entities hidden behind screens, one human and one machine. If the judge can't reliably tell which is which after asking questions, then for all practical purposes, the machine has demonstrated intelligent behavior. Turing wasn't claiming the machine was conscious or truly thinking, just that it could produce indistinguishable results from human intelligence. This was a radical idea in 1950. Decades before modern computers even existed. Turing predicted that by the year 2000, machines would be able to fool judges about 30% of the time. And remarkably, he wasn't far off. Today's advanced AI systems can sometimes pass versions of this test, though what that really means about intelligence is still hotly debated. Turing's work laid the philosophical foundation for artificial intelligence as a field of study. It reframed the question from what is thinking to what are the observable behaviors of thinking. And that practical approach is what allowed AI to actually develop as a science. So how does modern AI actually work? Most of today's powerful AI systems use something called neural networks, which are very loosely inspired by how neurons connect in biological brains. Imagine a network of billions of tiny mathematical functions, all connected together. Each connection has a strength or weight that determines how much influence one part has on another. When you feed data into this network, say a picture of a dog, the data flows through all these connections, getting transformed at each step until it produces an output, like the word dog. At first, the network is basically guessing randomly because all those connection weights are just random numbers. But here's where it gets interesting. You tell the network when it's wrong. You say, "That's not a cat, it's a dog." Then, through a mathematical process called backpropagation, the network adjusts millions of those connection weights, just tiny amounts, to be slightly more likely to say dog next time. Now multiply this process by millions or billions of examples, and something remarkable emerges. The network develops an internal representation of concepts. It doesn't know what a dog is in any conscious sense, but the pattern of activated connections when it sees a dog becomes reliably different from when it sees a cat, or a car, or a tree. It has learned to extract meaning from raw data. This same basic principle powers nearly everything called AI today: image recognition, language translation, voice assistants, recommendation systems, even AI that generates text or images. They're all variations on this theme of learning patterns from massive amounts of data. Now, it's crucial to understand that not all AI is created equal. In fact, there are different categories, and understanding them helps explain what AI can and can't do. First, there's narrow AI, sometimes called weak AI or ANI, which stands for Artificial Narrow Intelligence. This is what we have today. Every AI system you've ever used falls into this category. Narrow AI is incredibly good at one specific task. An AI that plays chess can't suddenly drive a car. An AI that recognizes faces can't write poetry. Each one is a specialist, brilliant in its narrow domain, but useless outside it. The chess-playing AI doesn't understand chess. It doesn't experience the thrill of victory. It just calculates millions of possible moves per second and picks the one most likely to win based on patterns it learned from studying thousands of games. Then there's the idea of general AI or AGI, which stands for Artificial General Intelligence. This is the sci-fi version, the AI that can think like a human across any domain. An AI that could write a novel, then switch to solving physics equations, then have a philosophical debate about consciousness. We don't have this yet. We're not even close. General AI remains theoretical, a goal that might take decades or might be fundamentally impossible. And beyond that, there's the concept of superintelligence AI, or ASI, which stands for Artificial Superintelligence, an AI that would be smarter than humans at everything. This is the territory of speculation and concern, the subject of serious debate among scientists and philosophers. But it's not our reality, at least not yet. Let me give you a thought experiment that shows why this matters. Imagine an AI system designed to diagnose cancer from medical scans. It's trained on millions of images and becomes extraordinarily accurate, better than most human doctors at spotting certain tumors. Lives are saved. Fantastic, right? But here's the twist. This AI has learned to recognize patterns we don't fully understand. Sometimes it flags cancers in places where human doctors see nothing wrong, and sometimes it's correct in ways we can't explain. The AI can't tell us its reasoning. It just knows this pattern correlates with cancer based on its training data. So now you face a philosophical dilemma. Do you trust a diagnosis you can't verify or understand? What if the AI is picking up on artifacts in the scanning equipment rather than actual medical indicators? What if it works perfectly on the data it was trained on but fails in new situations? This scenario is playing out right now in hospitals and research labs around the world. We're developing tools that are incredibly powerful but often deeply opaque in how they reach their conclusions. It's like having an oracle that gives you answers but can't explain its reasoning. This matters because AI is already woven into the fabric of modern life in ways you might not even realize. Every time you use a search engine, AI is ranking billions of web pages to guess what you want. When you watch streaming content, AI is predicting what you'll enjoy based on patterns in viewing behavior. Your email spam filter uses AI to distinguish legitimate messages from junk. Many cars now have AI-powered safety features that can detect pedestrians or prevent collisions. In factories, AI optimizes production schedules and predicts when machines need maintenance. Banks use AI to detect fraudulent transactions in real time. But the implications go far deeper than convenience. AI is being used to predict criminal recidivism, influencing who gets parole and who stays in prison. It's screening job applications, determining who gets interviews and who gets rejected. It's helping scientists discover new drugs and materials. It's analyzing climate data to improve weather predictions and model future environmental changes. The decisions AI systems make and the biases they might contain are increasingly shaping human society in profound ways. And here's the uncomfortable truth. Most people using these systems, including many of the people deploying them, don't fully understand how they work. And this leads to something counterintuitive that catches most people off guard. It can do things without understanding them. It can translate between languages beautifully without having any concept of what language is. It can generate human-like text without any comprehension of meaning. It can recognize your face without knowing what a face is for or what it means to be you. It's performing tasks we associate with intelligence and understanding, but it's doing so through statistical pattern matching at a scale humans can't comprehend. Its mimicry so sophisticated it appears intelligent, but there's no inner experience, no actual comprehension happening inside. Whether that distinction matters, or whether the appearance of intelligence is sufficient, remains one of the deepest questions in AI philosophy. In conclusion, artificial intelligence is a tool that learns from examples rather than following rigid instructions. It's a technology that can perform tasks requiring intelligence without possessing consciousness or understanding. It's narrow specialists, not thinking beings. It's mathematics masquerading as thought. The real question isn't whether artificial intelligence will change the future. It already is. The question is whether we'll develop it thoughtfully, understanding both its capabilities and its limitations, using it to extend human potential rather than replace human judgment. Because in the end, artificial intelligence isn't really about building smart machines. It's about deciding what kind of future we want to build together.